Good morning.
Good morning, sir.
Very good morning to all of you.
Good morning, sir.
Good morning, sir.
Good morning. So, in the last class, we have discussed about JFET. Okay, क्यों JFET के बारे में बात की थी ना? Hello.
Yes, sir.
Junction field effect transistors. So, we have these junctions here, two junctions, right? But it is unipolar as compared to NPN transistors. बस वही फर्क है. This is what we are getting here, right? These are the depletion layers. And we have discussed about the concept of pinch off voltage. This is nothing but pinch off. Okay, so electrons will move towards this side, right? And there is saturation at the pinch off voltage. So funnel type बन जाएगी ऐसे. Fine. So this is how it is going to move. This region of operation is, this is, we know, ohmic region or linear or active. Okay, because this is going to increase proportionally up to this point, and beyond this point it is saturation. Right, now today we'll discuss about MOSFET. Have you heard of this term? Hello.
No, sir.
Okay, so this is of two types. One is enhancement MOSFET, and another one is depletion MOSFET. MOSFET is nothing but metal oxide semiconductor. Metals, we can use aluminium, copper. Oxide, we are using silicon dioxide. Okay, और भी यूज कर सकते हैं HFO2, right, and Al2O3 like this. But we are using this, and we can use silicon or germanium semiconductors. So more precisely, we are using this. Okay, and if I take the pictures, So this is can you see it?
Yes, sir.
Right. So what we have is that this is the structure. Now, can you see it now? So
Yes, sir.
this gate is connected with metal. This part is metal. Second part, that is, I'm going to take this. This part is silicon dioxide. Can you see? And this part is metal. That's why it is something like two conductors separated by a insulator. ऐसे है ना? If you see here, ये क्या है? Aluminium, ये silicon dioxide, and this is silicon. This is metal. This is semiconductor. तो ये दोनों कंडक्टर हैं एक तरह से. And this is insulator. Have you seen this type of structure? दो metals हों, दो conductors हों, separated by insulator. क्या बनता है इससे?
Capacitor.
Capacitor. Okay? तो ये भी more or less एक capacitor ही है. Right? Now we have three gate. This is drain. This is source. And this is substrate. It is a 4-terminal device. Generally, substrate and source, they are connected with same power supply. ठीक है? उसको same power supply के साथ use करते हैं. So I hope you understand. So ये दो N है, separated by P-type substrate. This is N-channel MOSFET actually. Right? Now we'll see it's working. अब देखते हैं. So now if we see it, what we do is, because this is enhancement type and MOSFET, so there is no channel here. अब देखो जैसे if I apply a voltage here, okay, मान लो VDD अप्लाई की, this is drain, this part is drain, ये drain है, it is connected with this N, ये source है, it is connected with, एक तरह से इस तरह से है, okay. So what we have is we have a p-type junction here. यहाँ पे क्या है, p-type है, ये p और n है, so definitely there will be some depletion layer. This positive is connected with n, so इस साइड ज्यादा होगा ना depletion region. Hello, yes
यस
or
सर
no,
ज्यादा
है ना?
Yes, sir.
ये depletion region मीन्स अगर BDD अप्लाई करता हूँ मैं, कोई गेट पे कुछ नहीं देता हूँ, तो ये डिप्लीशन रीजन है एक तरह से, सो कोई करंट फ्लो होगा, व्हेन पीएन जंक्शन इज रिवर्स वाइज कौन सा करंट फ्लो होता है, एक तरह से ऐसे है, विच करंट इज फ्लोइंग, हेलो, लीकेज करंट, राइट, विच इज बिकॉज ऑफ माइनॉरिटी कैरियर्स, ठीक है,
Yes, sir.
and that current is in nanoamperes, very small, so generally we neglect it, and majority carriers की वजह से कितना करंट होगा, नो करंट, राइट.
Yes, sir.
अब हमें क्या करना है कि हमें इस डिप्लीशन रीजन को रिमूव करना है किसी तरह हमें, है ना, और ये पी जंक्शन है यहाँ पे, अगर इसको हम यहाँ क्या करें, इलेक्ट्रॉन्स ले आए, क्या ले आए, इफ वी हैव इलेक्ट्रॉन्स हियर, हियर, इसको भी एन बना दें किसी तरह से, क्या बना दें, एन, सो ये सारा रीजन क्या होगा, इट इज फुल ऑफ
N type.
इलेक्ट्रॉन्स, राइट.
Yes,
तो
sir.
यहाँ इलेक्ट्रॉन्स कैसे आएंगे, व्हेन वी अप्लाई सम पॉजिटिव पोटेंशियल हियर, तो क्या होगा, बिकॉज दिस इज गेट, so electrons from here will be attracted towards this side, isn't it, because in p-type substrate we have electrons also, minority में है लेकिन है, so these electrons which are here they will come to here, यहाँ जाएंगे, they will not go to this side, why, because we have insulator in between that, यहाँ है ना insulator, this is insulator, okay, so they are going to accumulate here if we apply positive potential here. अगर यहाँ पॉजिटिव पोटेंशियल अप्लाई करते हैं गेट पे, तो दूसरी साइड से, बिकॉज दिस इज लाइक ए कैपेसिटर, तो इफ वी हैव पॉजिटिव पोटेंशियल हियर, दूसरी साइड कौन सा होगा,
Negative.
नेगेटिव, तो यहाँ भी वैसे ही है. अब अगर यहाँ नेगेटिव आ गया, इसमें भी इलेक्ट्रॉन्स मेजोरिटी में है, तो वी हैव ए चैनल ऑफ इलेक्ट्रॉन्स हियर, ओके, तो क्या होगा, this positive is going to, because ये डिप्लीशन लेयर खत्म होगी, हमें क्या मिल रहे हैं? इलेक्ट्रॉन्स मिल रहे हैं, यहां से खत्म होगी ना डिप्लीशन,
Yes, sir.
राइट? बिकॉज यहां पे सप्लाई अप्लाई करके हमने यहां we have made a channel of electrons here, right? So there is flow of electrons. इलेक्ट्रॉन्स कैसे फ्लो करेंगे? इस साइड को, टुवर्ड्स दिस साइड, ऐसे जाएंगे ना इलेक्ट्रॉन्स,
Yes, sir.
इस साइड. So current is like this one, right? And if I'm applying the negative potential here, तो क्या होगा? तो ये सब रिपेल हो जाएगा. So अगर नेगेटिव पोटेंशियल यहाँ अप्लाई करता हूँ, ओके, अगर यहाँ नेगेटिव अप्लाई करता हूँ तो यहाँ क्या आ जाएगा? पॉजिटिव. So this is going to enhance the depletion layer, right? ऐसे
Yes,
होगा
sir.
ना? So what is current? 0. And if I जैसे नेगेटिव अप्लाई कर, what is gate current? 0. क्यों? Because of this, we have a insulator here, है ना? हमारे पास क्या है? Insulator, this one. So there is no flow of current like this. इस साइड को करंट कितना होगा? 0, because insulator doesn't allow any conduction. Any questions regarding this working now?
No, sir.
So this is the book which you have to follow. ठीक है, ये अच्छी बुक है, आप इसको फॉलो कर सकते हैं आराम से. ओके,
Yes, sir.
ओके, तो समझ आ गया ये जो मैंने बताया?
Yes.
So we'll talk about its working now. So yeah, this is what we are applying. Now we'll see it's working further. Okay, so question is that this channel, how it is being formed when we apply the positive potential here. जैसे अभी अप्लाई किया हुआ ना, this one is positive. So there must be attraction of the electrons. What? जो VDG है, that means VDS minus VGS. Okay, or VDS plus VSG. VSG ऐसे भी लिख सकते हैं. So this voltage and this voltage. Suppose I am applying this 10 and I am applying this 5. So net, that means VD minus VG. So if you increase the VGS, so this VDG is going to decrease, isn't it? Am I right? So gate to drain voltage, this voltage, this is VDG, it is also coming down if I am going to increase this, right? So gate is becoming less negative as compared to drain, क्योंकि ड्रेन हायर पोटेंशियल पे हो जाएगा, गेट लोअर पोटेंशियल पे हो जाएगा. सो इट्स इम्पैक्ट मीन्स अगर इसमें लेस इम्पैक्ट है, सो इट कैन नॉट अट्रैक्ट मोर इलेक्ट्रॉन्स फ्रॉम हियर, और जितना ही ड्रेन से दूर जाएगा, इट इज हैविंग मोर इलेक्ट्रॉन्स, बिकॉज ड्रेन का इम्पैक्ट कम होगा टुवर्ड सोर्स, बिकॉज सोर्स पोटेंशियल इज 0. ओके, तो VGS इज वो सेम रहेगी, बट ड्रेन वाली साइड को इम्पैक्ट इज वेरी लेस. That's why if you see the channel here, that is more towards the source and less towards the drain. This region is called as pinch off. ये भी वही फनल वाला सिस्टम बन गया एक तरह से ऐसे. क्या बन गया ये? ऐसे फनल. कि यहां से सोर्स से जितने मर्जी इलेक्ट्रॉन चलें, लेकिन दूसरी साइड जाके वो एकदम कांस्टेंट हो जाएंगे. दिस फ्लो इज कांस्टेंट. तो ये कांस्टेंट ही रहेगा. एंड दिस सिचुएशन इज कॉल्ड एज पिंच ऑफ. एंड ट्रांजिस्टर मूव्स इनटू द सैचुरेशन. मींस अगर बीजीएस को इंक्रीज करेंगे तो ट्रांजिस्टर पिंच ऑफ में जाएगा. राइट. तो ये भी फनल टाइप शेप है एक तरह से. दिस वन इफ यू सी दिस वन फनल की तरह बन रहा है ना ऐसे. लाइक दिस. इस तरह से. ओके. सो यहां से कांस्टेंट करंट फ्लो करेगा. And that situation is called as pinch off. Right? And if we see its characteristics, तो ये characteristics हैं. That in the beginning, the current starts. जैसे इसको इंक्रीज कर रहे हैं तो VGS इंक्रीज करेंगे तो चैनल में इलेक्ट्रॉन्स बढ़ेंगे. But at this point, if we are going beyond pinch off, this is going to move into saturation. And this is linear. So this region we know it is linear because it is increasing. And as we increase this BGS, we can increase the right. So if we increase the gate voltage, we are able to increase the channel. And this is called as channel. A channel. So that's why its name is N-channel enhancement type MOSFET. Okay. I hope you understand this reason. And we have a minimum threshold voltage before the channel is being formed. Right? तो उसको बोलते हैं threshold. That means ये है. जैसे ये बनाया हमने MOSFET. ठीक है. बुक्स में ऐसे भी बना होता है. This is N, this is N, this is P. That is substrate. This is gate. This is drain. This is, or we write it VDD also. So when we apply positive potential here, electrons will attract towards this side. So current is flowing. But we have to apply minimum BGS so that a channel is being formed here. This is channel. So you need some minimum amount of electrons here so that ID flows. कुछ तो चाहिए ना minimum. So the volt potential, if it is less than threshold voltage, the current is, if VGS is less than that threshold voltage, ID is 0. So if VGS is greater than equal to VT, ID starts flowing. Okay. So that is called as threshold voltage. Okay. Right. So the purpose of this is, the gate voltage is, VGS का क्या purpose है? To form the channel. And once you are able to attract these electrons here, VDS का क्या काम है? To move those charge carriers and make it conducting. Means ऑफ स्टेट से ऑन में लाना है या ऑन से ऑफ में करना है, राइट? सो ऑफ स्टेट से ऑन स्टेट में लाने के लिए. So once channel is being formed, you can flow, or there is flow of charge carriers, and that is how the current is going to flow. ठीक है, जैसे ये है, ये बुक के हिसाब से दिखा देता हूं आपको. बुक में ऐसे बना हुआ है. इस तरह से, दिस इज N, दिस इज N, ये है SiO2, and we have metal here. ये गेट है, ये मेटल है, silicon dioxide. When we apply the positive potential here, we are attracting the electrons from the P substrate. This is substrate. Okay. Electrons will reach up to this. In order to move these charge carriers, we are applying the VDD. Okay. So that is how the ID current is going to flow. If you have to turn it off, you just have to apply the negative potential here. And now we can turn it off, because negative is going to attract the holes towards this side. So this PN junction is becoming a problem here. So this is having a depletion layer here. Right? I hope you understand this. Just please write yes or no if you understood this. Hello. ये Right. Now there is one another, and if I go for this, so this is the formula for this, that in saturation ID is equal to K BGS minus VT whole square, right? And K is nothing but ID on divided by BGS on minus VT whole square. Okay, so this is true for this value. So, but VGS, if it is less than VT, ID is zero straight away because no channel is being formed. मिनिमम चैनल बनाने के लिए और करंट फ्लो कराने के लिए मिनिमम चैनल होना जरूरी है. ओके, and this is how we are symbolizing them. M channel because electrons will move. This is the difference actually. हम थोड़ा सा गैप रखते हैं. अब आप देखो ना, there is a gap between these two lines here. That is because of silicon dioxide. Okay, insulator basically. So this is N channel. And there is another type of this. This one. This is depletion type. Can you see it? Depletion type. So here, if you see this one, a channel is already being formed here. ठीक है? A channel is being formed here already. यहाँ बना ना N. Okay? Hello?
Yes, sir.
So even if we apply the PDD here, अगर इसको अप्लाई करेंगे तो करंट फ्लो होगा. बिकॉज सारा चैनल बना हुआ है. बना है, बनाने की जरूरत नहीं है. ठीक है, इवन इफ दिस गेट वोल्टेज इज जीरो, अगर ये दोनों ग्राउंड है तो मीन्स बीजीएस जीरो भी है तो यहाँ चैनल बना हुआ है. हमें इलेक्ट्रॉन्स खींचने की जरूरत नहीं है यहाँ, राइट, टू मेक द चैनल हियर, and current is going to flow by applying this VDA. So even at 0 volt, we can apply this. Or if we have to attract the more electrons, we have to apply the positive potential here. So more electrons will come and we can increase it, the ID further. Okay, but even if at VGS is 0, okay, and threshold voltage is also 0 because channel is already formed here. So if you see its characteristics, अगर इसकी characteristics देखें, So if you see here, so at 0 also there is some current flow, and in this case we have a threshold voltage. So here if VGS is 0, even though there is some current, that is the difference. So ID is there even if VGS is 0 volt. We have this ID, right? तो ये फर्क है दोनों के उसमें, बाकी फंक्शनिंग सेम है. Okay, so generally we are not using this depletion type MOSFET. Okay, we don't use depletion type MOSFET. Nowadays we are using enhancement type. Enhancement type MOSFET is being used for every application. जैसे why its name is enhancement? Because it is going to enhance this channel. Initially channel is, there is no channel. Even if you apply the VDD, अगर BDS या BDD जो भी बोल रहे हैं इसको अप्लाई करते हैं, there is flow of current? No. But when we apply this positive potential here at the gate, only then channel is being formed. Channel is being enhanced actually. That's why its name is enhancement type MOSFET. So if you see, if VGS is negative, N channel MOSFET is off. And if VGS is positive, N channel MOSFET is, or it will start conducting actually. So VGS greater than VT in fact. Only then it is turned on. Am I right? Okay.
Yes, sir.
Right? So this is true for N channel MOSFET. And if VGS is positive, N channel MOSFET is on, P channel MOSFET is on, and if VGS is negative, P channel is, उल्टा कर दिया मैंने. It is, if it is negative, P channel is on, P channel is off. Let us see P channel. This is P channel में ये दोनों P होंगे, source and drain. This is drain, this is source, and this is gate. This is gate. For making the channel, we need negative potential here, so that we have holes attracted towards this side, and a channel is being, so this channel is being formed, isn't it? So for P channel MOSFET, this is N type, substrate is N type. So we have to apply it like this. Negative, positive. So holes will be attracted towards this side. We have a drain current. So this is P channel MOSFET. And we have to apply the negative potential here. Okay. So by application of negative, P channel is on, right? And again we have a threshold voltage here, because below that voltage the channel is being not formed. This is channel, and the current is not going to flow, or MOSFET is conducting or non-conducting. Okay, so इनिशियली ऑफ है. इफ हम एम चैनल की बात कर रहे हैं, मान लो BGS is 0 हो, so it is off, right? ऑन करने के लिए BGS should be greater than VT. It will start conducting and it will move into linear region. And when VDG starts decreasing as BGS starts increasing, because channel is becoming pinch off again, so transistor going into, or this ID becomes saturated and it starts moving into saturation region. ठीक है? Okay, so symbol of the NMOS and PMOS can be like this also. एक bubble बना दिया था, तो this is becoming PMOS, right? This is drain, this is source, this is gate. If we make a circuit like this is VDD, this is ground, this is V input, this is V output. Suppose if input is positive, this is ground. Okay, so PMOS should be on or off, because for BGS positive, PMOS should be off and NMOS should be on. So this circuit is something like this: VDD, PMOS is off and NMOS is on. So V output is connected to which point? ये तो open circuit हो गया, and this is short circuit. So if you see, this is connected with this V output. V output कितनी आ जाएगी? 0, because this is 0 volt, right? So P output becomes 0 volt. If V input is equal to VGS is equal to negative, suppose, so PMOS is on, NMOS is off, right? तो क्या होगा? This is open circuit, this is short circuit. This is VDD, this is V output. What should be the output? Output कितनी आएगी? This V output is connected to which point? VDD. So V output here is equal to VDD. So if you see, if V input is high, or this VGS or V input, कुछ भी ले लो इसको. If it is high, the output is connected with the ground. If VGS is low, 0, so this is connected with VDD. So ये high है, ये low है. अगर ये low है, तो output high है. This is called as complementary MOSFET. MOSFET. PMOS and MOS, they are complementing each other. If one is on, another one is off. So, if input high है, output low है, means if you see, if input is 0, output is 1. And if input is 1, output is 0. Which gate this is? You remember? Any logic gate? This is which gate? NOT gate. NOT gate में ऐसे होता है ना? Hello?
Yes, sir.
Yes, sir.
Okay. So that is how we can use this. But we are using the enhancement type MOSFETs. Why we don't use the depletion type? Because it is turned on without any threshold voltage. So that is a problem with that. We just want to make it conducting and non-conducting depending upon its input. So if channel is being formed and at VGS is 0, there is no channel. So you can see it. And if we apply the VGS, then accordingly, PMOS or NMOS, they are on or off. So that's why they are complementing each other. Okay? Because one is on, another one is off. That is the technique which is being used. तो ये CMOS है, this is NMOS. इससे आप NAND gate, NOR gate सब बना सकते हैं. NOR, AND, OR. All the gates you can make with the help of CMOS. Right? So this is about the MOSFET. Any questions from today's class? Hello.